All right, these notes are going to show you how to graph inequalities when two variables are in them. We have already spent in a previous chapter time solving and graphing inequalities that have one variable in it on a number line. This is totally different. These are still inequalities, but they will have two variables in them and they will be graphed on the coordinate plane. All right, so before we jump in and do any of the examples and before I show you any of the graphs, the first thing I want to do is give you the steps of how to graph them. There is no other way to get the answer from these equations and inequalities than to graph them. It doesn't have a substitution method or anything like that, right? So you have to be able to graph these, right? So again, the steps may look a little weird and sound a little weird until I show you some examples and give you some pointers, but get them down and then we'll talk through and figure out what you need to know. All right, so the first thing you are going to have to do is graph using the slope and y-intercept, right, which means if it's not in slope-intercept form, you must put it there first. Right? And when you go to graph them, you've got your dots and you're ready to connect them, you have to use a dashed line for the signs of less than or greater than. Okay, and a dashed line looks like this, where there's breaks in it. I have got to be able to see that your line has been dashed, because if you draw it solid, it is wrong. Right? It is very picky on details when it comes to these graphs. Right? Okay. And then you use a solid line for less than equal to and greater than equal to signs. And a solid line is exactly how you've been making them. Okay, so just like the graphs on the number line, if it had a piece of the equal bar, you had to color in your dot, and if it didn't, you left it open. Well, think of this as an open line and a closed line. Open line has dashes, and a closed line is one solid line. Right, so that does help to put the two in perspective and kind of give you something to go off of from what you know from the past. Then the second thing that you have is the graphed line. So now that you got your line drawn, separates the coordinate plane into two halves. No matter what kind of line is drawn, it's now split into two halves. Okay? And at this point, you can test an ordered pair to see which side to shade. And this is known as a test point, right? So basically what it's saying is that you're going to graph your line first, and then you can test a point to see if you're supposed to shade on that side, if not the other side, right? And if you remember from graphing in a number line, we had to shade either to the left of the number or the left of the dot or to the right of the dot, depending on whether we had greater than or less than. Well, the same is going to hold true in the coordinate plane, but it's going to be on which side of the line should you shade, right? So that test point is kind of optional. If you use some common sense, you don't even have to do step 2. You can immediately jump to step 3. Okay? If the test point is a solution, shade that side of the line. If it is not a solution, shade the other side. Right, and this may not make a whole lot of sense to you until you physically see it being done, right? And then I do have some other tricks that I can show you. I have a trick that involves your hands and knowing which side to shade that I can show you in person other than through this video. But for the sake of the video, I want to see if you can basically just use some common sense of less than being underneath the line, greater than being on top of the line, and then you don't have to worry about a test point anymore. All right, but before we can do any sort of graphing, your directions to some problems may ask, is the ordered pair a solution? And we've done this before with equations, but the same question can be asked of an inequality, right? So if I give you, and I'm only going to do one of these because I think you'll catch on to them fairly quickly. If I give you the inequality of 2x plus 5y is greater or equal to 10, okay, and then I give you some order pairs to test. I want you to test out the order pair of 1, 2, and the order pair of 6, negative 1. Right? And because I'm asking you to test out two separate order pairs, you should have two separate answers. You have to do each one separately and then answer each one separately. So let's take the first one. And it's as simple as plugging in your x value and your y value into the inequality. Right? So if I plug in x is 1, this is 2 times 1 plus 5 times 2. And we want it to be greater or equal to 10. Right? So if I follow order of operations, 2 times 1 is 2, 5 times 2 is 10, 2 plus 10 is 12. Is 12 greater or equal to 10? We say yes, so that is a true statement. So because it is a true statement, then the ordered pair of 1, 2 is a solution, right? This is where you can have a whole bunch of solutions because it's not an equal sign. In an equal sign, you can only have one, right? But with an inequality sign, you can have a whole bunch of them because as long as it makes the equation true, then it'll work. So then if we test 6 and negative 1, we have 2 times 6 plus 5 times negative 1 is greater or equal to 10. 2 times 6 is 12, 5 times negative 1 is minus 5, 12 minus 5 is 7. Is 7 greater or equal to 10? That is not a true statement. That is no. So that means that the ordered pair of 6, negative 1 does not work. Okay, so you do not automatically, because you say yes to one, get to say no to the other one. You have to test them all out because it could be that every order pair I give you works. It could be that none of the order pairs I give you work, right? Or it can be that some of them do and some of them don't. So you have to test them out separately, and they do have to make a true statement before you can say yes or no. All right, so now we are ready to jump into the graphing method, right? Because other than testing out is it a solution or not, there's not much else to show you when it comes down to these. All right, so the first one we're going to practice drawing, and I'm going to start you basic so you can see what the idea behind this is we're going to graph x is greater or equal to 4. Okay, now because it starts with an x, right, then you're going to take and remember some of the things you remember from lines. Just because it's an inequality doesn't mean that you forget everything you did about equations. All right, a line is a line no matter what type of symbol it has in there. All right, so when we're sketching our pictures, and this is a sketch at this point, if you want to use graph paper, you certainly could have, right? But at this point, I'm going to use sketches for these pages of notes. Right? When you do actual homework assignments and things in class, you will be asked to use graph paper. All right, so for the graph of x is greater or equal to 4, it starts with an x, so that means I can remember about VUX, and because it starts with an x, it's going to be a vertical line, and it's going to go through positive 4. So 1, 2, 3, 4, and then I'm putting a dot. Now, before I draw my line, you have to ask yourself a question. Is it going to be solid or dashed? And because it has a piece of the equal bar, that means it's going to be a solid line through that point. Okay, so the line is drawn. Because it's an inequality, you also have to shade. Right? Now, because it says x is greater or equal to 4, this line has divided your graph into a left side and a right side. All the numbers bigger than 4 are to the right of that line you just drew. So we shade everything on the right-hand side. That means any ordered pair on the right side of that line will work in this inequality. Right? So your answer is in your picture. There is no ordered pair to actually give me. The picture says it all. So that's why you've got to really make sure that your pictures are good and that they're accurate so that you can show me what you need to show me. All right, so now let's take a look at the second one that I've got for you. This time you're going to graph negative 5y is greater than negative 25. All right, now before we can graph this, we do have to put them in intercept form. Right, that still holds true. Right, and in order to get rid of the negative 5, I have to divide both sides by negative 5. And remember that in inequalities, when you multiply or divide by negative, the sign has to flip the other direction. So it's not greater than, now it's less than. Negative 25 divided by negative 5 is positive 5. So that's the graph I want to take and sketch. So again, I'm going to draw my x and y axis. Okay, and because it starts with a y and has no x in it, I'm going to think about hoy. right? And that means that it's a horizontal line, and it's got to go through positive 5. So 1, 2, 3, 4, 5. So it's going to go through that dot, and it's going to be horizontal. But before I draw it, I need to ask myself solid or dashed. Always ask yourself that question. And if you notice, there's no piece of the equal bar, which means it has to be a dashed line cutting through that dot. Okay, and I do have to be able to see. If you make a mistake and you can't tell or can't erase it, write the word dashed and point to the line. That way at least I know that you corrected yourself without having to redraw the whole picture. All right, so now this line has split my graph into the top part and the bottom part. And it says y has to be less than 5. So all the values less than 5 are down here underneath that line. That means any ordered pair down here underneath that line will work for that inequality. Okay, and that's a lot of ordered pairs that you can see right now. Okay, so that's what our pictures are going to look like. So you either have vertical lines, you have horizontal lines, or we have slanted lines. And that's what the next one's going to be for you. All right, so for the next one, what I want to show you is one that has both variables in it. Right, and that's y minus x is less than or equal to 7. Okay, and when we go to do this, we can't graph it yet because it's not in intercept form, so we have to add the x over, so that now we have y is less than or equal to x plus 7. So now I know that my m is 1 and my b is 7, and I'm ready to hit the graph paper. Right, so I'm going to sketch my intercepts here, or my x and y axis. I've got to start at positive 7, so 1, 2, 3, 4, 5, 6, 7. There's my dot. And then to get to my next dot, I'm going to have to rise 1 and run 1. So up 1 and right 1. Or if you don't want to keep going up 1 and right 1, you can always go down 1 and left 1 and put your other dot. Now before you connect them, you need to ask yourself solid or dashed. It does have a piece of the equal bar underneath, which means it is going to be one solid line going through those dots. Okay? And then because it's less than or equal to, less than means underneath. So you want to shade all of the values underneath that slanted line, which would be this direction. Okay, now, if you wanted to test an ordered pair, all right, to see if you shaded in the right spot, all right, if you can look at it, it looks like my ordered pair of 0, 0. Always test 0, 0, because that's the easiest one to plug in. If I plug in 0, 0, I now have 0 is less than or equal to 0 plus 7, which means 0 is less than or equal to 7. Is 0 less than or equal to 7? Yes. So as soon as you say yes, then that means the ordered pair of 0, 0 must be in the shaded area. If you look at my picture, it's in the shaded area. If you didn't say yes to that statement, then it should not be shaded. The other side of the line should be shaded. So we can keep testing out 0, 0, but that's a really good one to use. And it's quick and easy as well, if you want to test to see if you've colored in the right spot. Okay. All right, so let's practice a few more. All right, we'll do one more of the ones where you have to graph, and then I'm going to sketch some pictures of graphs, and then we're going to write the inequalities that made those pictures, because you have to be able to do both versions. You have to be able to graph them, and you have to be able to write them from a graph, which for some people is tricky until you get the hang of it. All right, so here's my next inequality, and you'll notice that it's quite ugly looking. All right, it's got a lot of fractions that I don't want to deal with. All right, so I'm going to get rid of the fractions right off the bat, and we're going to multiply by 4 to make that happen. So 1/4 times 4 leaves me with x, half of 4 leaves me with 2y, and 4 times 1 is 4. And now I'm going to solve it for the y. So I'm going to subtract x. Oops, no equal sign. You have to be careful to catch yourself when you do that. It is a less than sign now. All right, so you have to subtract your x. So you have 2y is less than negative x plus 4. Divide everybody by 2. And your final inequality you're going to graph is y is less than negative 1/2 x plus 2. And that's what we want to graph here on the next grid. So you set yourself up your coordinate plane. And we put our b value at positive 2, which is right here. And then we have to go down 1 and right 2. Or you can go up 1 and left 2. I'm going to do both. So down 1, right 2 puts me here. Up 1 and left 2 puts me here. All right, and then before you connect, always ask yourself solid or dashed. There is no piece of the equal bar, so it is a dashed line coming through the dots. And extend it from one edge of your grid to the other. Right, and then you want to shade less than would be underneath the line. So that would be down here. And again, if you want to test it out, take that 0, 0. Okay, if I put 0 is less than negative 1/2 times 0 plus 2. Well, negative 1/2 times 0 is still 0. So 0 is less than 2. Is that a true statement? Yes, it is. So it should be colored, and it is. So you know you've shaded in the right area. All right, so that's to help you out with the graphing side of things. Well, now let's switch to the writing piece. Okay. And we will do a lot more practice with this as well in class. All right, so your directions are to write an inequality from the graphs. So I'm going to draw 4 graphs up here. And as I'm drawing them on my paper, you go ahead and draw them on your paper. And then once we get all 4 of them drawn, we will take and go back through and make sure that we know how to write the inequalities for them. And I'll show you exactly how to handle it and what to think about as you're doing this. All right, so for the first one, and again, just take and draw as I'm drawing. And this should give you plenty of time to draw them on your own paper while I'm doing my part. All right, so there are the 4 graphs that we will be answering the questions to. All right, and you have the pictures drawn for you, so that's not the issue. The issue is now taking the pictures and coming up with the inequality that makes them. All right, so let's take number 1, for example. We see that it's a vertical line, so as soon as you see the vertical line in your head, VUX should be popping up to your mind, right? Which means that it is a vertical line, so it has to start X, right? And then it's going through the number of -2, so that means X and -2 are part of your piece. Now, if you notice the shading, it is shading to the left of that line, which means all the numbers to the left of -2 are smaller than -2. So it is X is less than -2. And then always ask yourself, do I need the equal bar? And the answer is no, because it's dashed. Because dashed, remember, is less than or greater than with no equal sign. So that graph is X is less than -2. Now, when you go to number 2, you have to know the M and the B before you can write your inequality. So the first thing we want to pick out are those 2 values. The B value is your y-intercept, which is at +3. And then if you were to do rise over run, you would have up 3 and left 2. So that's 3 over -2. And that's your slope. And you notice it's solid. Sorry, so that means we're going to have y. We'll skip this part for the sign. And you have 3 over -2x plus 3. Right? And then you have to determine the sign. It is solid, so you need a piece of the equal bar. And then if you notice with that line, it's shaded underneath it. So that would be less than or equal to that piece. Okay, for number 3, you have another slanted line. Remember, every slanted line has a y and an x to it, right? Which means you have to figure out the m and the b. The B value on this one is -2. If you do your rise and your run, that's +5 over 1, which is just +5. So when I put it all together, I end up with y, skip the space for the sign, 5x minus 2 is the other side. Now it is a dashed line, which means no piece of the equal bar, and it is shaded underneath. So y is less than 5x minus 2. And then if you go to number 4, you'll know it's a horizontal line, which clues you in to say hoy, which means it has to start with y. It goes through the value of positive 4. It is a solid line, so it needs a piece of the equal bar, and it is shaded on top of that line, which means all the numbers above the 4 is y is greater than or equal to 4. Right? So this is what we'll be practicing with both in class and for a continuation through the homework. So use these notes as a reference and to help you out as you go through them.